Vadodara chapter. We will first have a look at the ISRE introduction video.
Chapters and sub-chapters spread all over India, bringing our entire We, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISRE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISRE disseminates knowledge through its technical committees, which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal, distributing the wealth of knowledge to all its members. Working with government departments, ISRE helps formalize industry codes and standards. ISRE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems, and processes. Our educational wing, ISRE Institute of Excellence, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISRE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISRE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, Acrex India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interactions amongst the decision makers in the industry. The Acrex exhibition is now growing from HVAC and R show into BFA, Build Fair Alliance. This brings together several allied shows connected with the building services industry all at one location. Our chapters organize several other popular events like AgriConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests, and site visits. A-Quest, a prestigious quiz competition organized by ISRE to catalyze the transformation of the budding engineering professionals. ISRE provides a platform to potential employers to select student members for careers in HVAC and our industry at the ISRE Job Junction. Young minds are made aware of the need for saving power, clean air, and sustainability. The K-12 initiative of ISRE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVACR and building services industry with just a few clicks. ISHRAE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection, and energy efficiency and conservation. To enter and explore the universe of the Indian HVACR industry, log on to ishray.in that unfolds a panorama of information. Let us engineer a sustainable future together through ISHRAE.
Moving forward, I would now request everyone to be ready for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय
Now I would invite Dr. Jignesh Mehta sir to give introduction of our today's guest speaker, Mr. Arpan Kedia.
Good afternoon to all student members, and I welcome Mr. Arpan Kedia. Mr. Arpan Kedia, probably you have already read his profile. He is an ISHRAE member, and he was there, I believe, for a couple of years at Vadodara. So we came to know each other, and then now it is like a lifetime bond probably for us. And so every time I think of air conditioning, I like Mr. Arpan Kedia immediately comes to my mind, and his experience is, of course, we will be able to use for the benefit of the students. And to give his introduction in brief, he has got his MTech from IIT Kanpur in solid mechanics and design, and he has around 10 years of experience in various domains of HVAC industry, heating, ventilating, air conditioning industry, right from design, planning, and execution. And now he is in the R&D team at Noida with Blue Star. So I invite Mr. Arpan Kedia to like light up the audience on the topic, the air handling units.
Thank you, Dr. Jignesh Mehta. I'm just sharing my screen. Is it visible?
Yes.
Yeah. So today's topic is the air handling unit and its component. So maybe most of the students who is seeing first time, and for them it's new topic. So you can ask any questions anytime, either by raising the hands or in the chat box. You can drop the question. We will discuss one by one. Today's I will show what are the components into the AHU, its use, how, what are the parameters we can see during the selection of the AHU. इसके अलावा size dimension of the AHU. Mostly whenever you work in the AHU field, the architect will ask you the dimensions. What will be the dimension? How how you can minimize, reduce the width or height you can do. So different parts we will go through. So I will go through slowly. If you find any questions in between, please feel free to ask. So first AHU, what is AHU? AHU is a kind of metal box, means you have seen the duct or any, for the time being you can consider a room is a metal box in which you put the fan, filters, heating coils, cooling coils, and the attenuators, mixing chambers, dampers. All these meanings I will show you in the pictures one by one. Ventilators for supply and exhaust. Ventilators means here it's meaning of fan for the supplying of fresh air or the conditioned air into the room is through ventilators, mean through fan. And that once the conditioned air is utilized inside the room, then it is going back to either to the atmosphere or it is going back to return to the AHU. So for that also sometimes we need the additional fan or sometimes we use single fan. Other than this, there is a heating coil, cooling coil. Why we need cooling coil? For example, the temperature of the environment is around 50 degree, 35, 40 degree. So 40, 45 degree temperature, and if the air of the same temperature will come inside the room, it is very difficult for us to, it's very uncomfortable condition for us. So we do the conditions of the air. So in which we bring down the temperature, humidity, and also air cleanness. Air movement is also required. So these 3-4 things we do inside the AHU, and we will circulate the air in the conditioned space. What is conditioned space? Conditioned space basically is the room where you want to do the conditioning. So filter is required for removing the dust particles or the odors or the harmful bacteria and all these things. Filter is required. So different industry, different kind of filters is required and the different uses. What is dampers? Dampers is basically to modulate the flow. Means if the room is required 100, for example, 1000 CFM, but if there is no one is here, then it can come bring down to the 100 CFM or below that. If the number of people is more, then the damper will open more than 60, 70, 80%, then the CFM will increase like that. So what is basically the function of AHUs? So function of AHUs, as I explained earlier, it takes outside air, recondition it and supply it to the building or condition space. The AHU mainly used to control these 4 components: temperature, humidity, air movement, air cleanliness. So if you remember in the psychrometric chart, if you have read it, so in the psychrometric chart, generally the comfort conditions, what we see is 25 degrees Celsius and humidity is around 50%. Air movement is required because if air is not moving, so it will not feel you the give the feelings of the cooling effect, or air cleanliness is required for our health. So basically AHU is defined into the two-way draw through AHU and blow through AHU. Both are having their own advantage. So draw through AHU, what will happen in that? Condensation of water is lower. Condensation of water is what? Whatever the moisture is present inside the air, it will get condensate when it is passing through the coil. Wait a minute, just. So this is coil. When you see minus sign, it means cooling coil. If you see plus sign, it means heating coil. Why minus? Because it bring down the temperature. Why plus? Why heater? In heater, it's plus because it's increase the temperature. So if you see there is three parts, it's 1, 2, 3. So air is coming from this side and passing through the cooling coil, and by this fan is sucking and supplying it to the conditioned space. So what will happen? The conditioned air here, it will get in temperature will get increased. Why? Because the motor is present here. So motor will dissipate some heat, and the whatever condition you have done, uh, whatever capacity is coming in terms of TR or kilowatt of the AC air handling unit, it will deducted by the amount of heat is adding into the cooling coil. So this is called draw through. In the blow through, so it is after it is before cooling coil. So whatever heating is generated here into the air, so it will passing through the cooling coil. So though there is no additional heat is present here. But advantages of this is the low condensation of water. Why low condensation? There is low load, less air leakage because it is blow through, draw through. Here it's pushing, here it's sucking. So this is the two types of arrangement if you find into the AHU industry. It depends on the requirement. So AHU and its major component. So this is one of the kind of AHU. You will find this, it's a double decker kind. You will find the single decker also. So different combinations you will find. This is the most typical one. So I'm just showing it to you. Here is the here the different sections. If you see, this is the cooling coil. Cooling coil in which there is one side water will go, other side water will come. So from this coil, the air will, if air is passing through this, air outside temperature is 30 degrees Celsius and cooling coil temperature 7 degrees Celsius temperature coming in and 12 degree coming out. So this is just example. It is not necessary that 712. It's a standard, but it may be 813, 914 depends on the applications. So 7 degree going in, 12 degree coming out, and outside ambient air temperature is say 40 degrees Celsius. So once it is passing through the coil, what will happen? The heat is getting transferred. Heat is getting transferred from this coil to the air. Air temperature will bring down from the 30 degrees to 15-16 degrees Celsius, while water temperature is getting increased from 7 to 12 degrees Celsius. The coil function of is this. There is a filter. If you see, there is a filter here. So what exactly filter is do? Filter is do there is dust particle into the atmosphere. So it arrests the dust particles and pass the fresh air to the conditioned space, so that you will get better conditioned air without any dust particles or the bacteria, germs, etc. So this is the inspection doors or handles. In what will happen? There is a inspection doors. There is 3-4 doors is present for closing the entire AHU. So in which there is a inspection door in which from here you can see this is a glass. From the glass, inside the glass you can see that the fan is rotating or not, or the condensation is happening or not. Few things you can see, and from the door, if you open the door, it will get closed. So in the AHU there is a one safety features. So whenever you open the door, there is a door limit switch. It will disconnect the electrical circuit and AHU get shut down. So during that, if you want to do maintenance or if you want to do any activity, you can do it. So this is the fan. Fan is also using different kinds, means forward curve fan, backward curve fans, and the uh, EU fan. So different kind of fans depends on the requirement, and every fan having the different cost. So according to that, this you see the dampers. This is called dampers. It is now in the closed conditions. So this is the blade. So it will get opened, and this opening is done as per the requirement of the fresh air, exhaust air supplier, like that. So this is the opening from the air it passed through. So it may be modulated, depends on the how much air you want to modulate it. This is the motor, fan motor basically. So this is the fan. Sometimes fan and motor is coming as in the isolation parts. So they are connected via belt, or sometimes it is directly connected with the fan itself. So this is the control system for controlling the fan, motors, and the other accessories like the dampers, if it is modulated dampers, and the controls related to the speed of the fan, how you are going to reduce or increase. For that, this control system is required. So nowadays energy saving is required. So basically all the client, consultant, architect demands the VFD operated fan. Why VFD operated? So if VFD operated fan is there, so it reduces the speed of the fan, it will save the energy. And if energy is getting saved, you will save the operating cost. This is the base frame. If you see, this is the green color base frame. So this base frame basically we provide, they provide to isolate the metal parts to touching each other. So what will happen? This is called thermal break profile. So inside the air temperature is coming around 14-15 degrees Celsius. So there is a panel. This is called panel. So in the panel, inside the panel, there is a insulation, different kind of insulation, say the fiberwood glass or nitrile rubber or the puff. Puff panel is the best one. So the puff panel, what will happen? It try to reduce the heat transfer from inside to the, sorry, outside to the inside. So because of this, condensation is happening. So to isolate all these parts, there is a thermal break profile. So it will avoid to continuous connection between the two metal parts.
Hello.
Yeah.
Yeah, Arpan sir.
Huh.
When you are using VFD, still, what is the need to use dampers? And is the operation of dampers automatic or it is manual?
See, dampers, the two types of dampers is coming. Basically three types. One is on-off type, other is manual, third is modulating type. So dampers is required first. For example, VFD at 100% you have given. So at 100% it is giving 10,000 CFM capacity. But if the damper opening is much more, then you can't control the airflow. So damper is required. It is required necessarily. Dampers at each end. For example, the fresh air you want 50 CFM or 1000 CFM. If the damper size is more, the VFD will suck. The VFD will only operate fan. It will not. It has no control with the air coming from the outside. So it may suck more because the less resistance path will suck the more CFM, more flow. So for that we have to modulate the dampers as per the balancing of the how much CFM is required. According to that we modulate. So whenever we use the BMS system or the building automated system, at that time what will happen? We try to give every dampers is the with motor. This is the manual kind of dampers you can say. So if for operating anything through BMS or automated system, we need the dampers with modulator actuator. So it operates as per the signals, temperature or the pressure difference it operates. Hope it is clear.
Yes.
Yeah. So basically I'm explaining the heating coils in details a bit. So AHU is also defined in terms of the cooling elements. There is a cooling elements refrigerant or chilled water. So in the small buildings, there is not possible to provide the chilled water. Chilled water is coming from where? It is coming from the chillers itself. So it is not recommended that you use the chiller everywhere because it's cost more and energy consumption for the smaller products, it will huge. So it's better to use the refrigerant. For example, if you want to, there is 3-4 rooms in your office. So it's better to you go with the refrigerant system in which AHU and there is one ODU kind of systems. while the chilled water is required for the big buildings, there is a number of AHUs required, and one chiller is operating n number of AHUs. So there are two different coils. If you see one coil with there is one coil in which the every copper tube is connected through distributor. While here you can see there's a dia is more, in and out dia is more, and if there is two heater, there is a two header is basically in which from one water is going, another is water is coming. So this is the chilled water coil. This is the refrigerant in which we said DX system. So here in the chilled water coil, if you see, there is a chilled water in which butterfly valve to isolate the system, wire strainer, because from this any foreign particles, any the dust or the some small particles which coming from waters or the rusting, everything is getting arrested here. Then pressure gauge, how much pressure is there, how much temperature, drain, if there is anything need to be drained. So there is a difference between drain and purge. Drain is for draining the water and purge is for removing the air which is arrested into the air cooled system. So again, inside written chill water in, chill water out, temperature, pressure. Then there is this is a system. If you see from closely, you can directly connect. There is a pressure two-way valve. Two-way valve with balancing valve. Basically, it is earlier there is two valves coming. One is the control valve, another is the balancing valve. Why balancing? Balancing is required to how much water should go through this AHU unit. So and it operates through via pressure to control valves. So there is combined two-way valve here is present. So basically we provide the bypass butterfly valve. If there is some problem into this two-way valve, we will remove it and do the service. But for that, at that time, at least the AHU system is running. So we will close these two valves and these valve will open at that time, and it will bypass this line, and it passes through this and it will continue. So Coil also designed it is also some vendors is giving with AHRI certification, some vendor is not giving. So for AHRI certification, it's AHRI 410, in which in coils the material is, you can see, fin materials, aluminum fins, copper tubes, and the galvanized or stainless steel casings. Basically, this casing is steel. Aluminum fins basically of you can do the blue fins coating or the black gold coating. Basically for Mumbai, there is salty area. So in the salty area, if you find the corrosion will happen. So to increase the life, you have to add some coating. So this is the blue coating, and the copper tubes, coil types, water type, water condensing. So this coil we are using for the evaporation purpose. So this is the chilled water coil, and if you use this similar coil in the condensation purpose, then condensing coils. So direct expansion coil this is. So different of coils is there. So corrosion resistance coating we are doing. So like this. Fan and motor. As I said you earlier, the different of fans they are using. Direct driven fan, DID to do forward centrifugal, backward plug fan. So selection, whenever you want to buy a new fan or any inquiry is coming, basically these 4-5 components they mention. So what is the applications? What is ESP means? External static pressure. So there is two types of pressure, external and internal. Internal, which is when air is passing through the fan, then there is some pressure drop. And other than this, the air is passing through the AHUs and the grill, diffuser or ducting, etc. All these pressure drop is called ESP. CFM basically is a cubic feet meter. Sorry, cubic feet per minute. So in which how much CFM is required? CFM means airflow. airflow, how much airflow is required inside the conditioned space or anywhere. So according to that, it is getting selected. Noise is the most important criteria which people mostly ignore in during the buying the equipment or anything. For example, if you are purchasing the fan for the school building or the hospitals or the hotels, so if the AHUs or fan or anything is too much noisy, at that time, what will happen? The patient or the student or the guest in the hotels, that they will get disturbed and they will try to avoid these kind of facilities. So there is no use when if the noise is more. So velocity for what? Velocity of air. Velocity of air, as per the standard, they say it should not be more than 500 fpm. If it is more than 500 fpm, there is velocity air cutting noise, and if it is passing through the coils or anything, it will reduce the life if the velocity is more. So backward curve fence and forward curve fence, though two types of blades is coming. In the backward curve fence, what will happen? It is more used when the external static pressure is more and ducting size is more. While forward curve fan is the used when the noise required is less and for the low distance or low static basically. So the motors nowadays is coming of different types, IE2, 3, 4. So IE2 is the energy efficiency motor in which if you see the efficiency is continuously increasing. So different types of motors is using depends. Whenever the efficiency increase, the cost will increase. So you have to check it is viable to use the IE4 for the smaller applications, because whenever you spend more energy, you have to recover from the energy from the electricity bill. So it will reduce within 1 or 2 years. Otherwise, there is no use. So the in this, if you see the motor, so there is a motor efficiency, motor rating, how much pressure drop, volume flow rate, how much volume flow rate. This is in CMH or liter per second or CFM. All these three things are same. Only the unit conversion you have to do. Installation, for installation, anti-vibration mountings is required or directly on the by using the some pad or something. Impeller material is with different kind. Control unit, how to control. So VFD also called the frequency inverter drive. You can also call it. So these are the filters, primary filters, secondary filters, or the tertiary filters. Primary filters is the basic filter that you can use and you can clean by water or anything. And this is the back filter in which the efficiency of the primary filter is lower, and then back filter, then the HEPA filter. So first here the the large particle will get arrested, then the whatever is filtered the particles, it will get arrested into the back filters, and after that it will pass through the HEPA filters where all the small 99.97% particles get arrested of the 0.03 micron. So you will get the HEPA filter best, but it's costly also, and it has to be use and throw. You can't be clean it. So this kind of HEPA filters is used in the special purpose like the pharma industry or the ISRO research centers or some in the electronics parts is you are going to make, or the hospitals, operation theater, isolation room like that. So these are the two. There is a different nomenclatures. So as per EN 779 European standards, Eurovent or SRA, there is other standards MERV, MERV. So equivalent material EU3, G85, EU3, G90, different of kind of class is defined for the filter. So if you remember, I told you that double skin points means panels. There is a two GI sheet or the steel material in which there is a puff material is injected. So for isolating the puff insulation is injected for outside heat is not going inside the AHU. It will also reduce the noise. If the thickness is more, the noise reduction will be more. So this is the drain tray. What is the use of drain tray? Drain tray use the it is basically present below the evaporating coil. So whenever the hot and humid air is passing through the coil, so what basically chilled water coil or evaporator coil is do, it re, it remove the humidity and bring down the temperature. So whenever it removes the humidity present into the atmosphere, so condensation will happen. Condensation will come in terms of the water droplets. So water droplets will accumulate here and continuously it will get accumulating and it will pass through the drain tray. And drain tray we will throw the water outside the building or through some trench, anything. So UV lamp also required inside the AHU. Why UV lamp will provide? So UV lamp will provide if there is in the hospitals or anywhere in the pharma industry, if there is any germs or any kind of bacteria is present. So because of the moisture is present in the drain tray, at that time what will happen? So there is chances of growing bacteria or any kind of disease can. So for killing that, UV lamp is required. But whenever you use UV lamp, you have to make sure that the UV rays should not affect any living organism. Means either us or the any rats or anywhere, because it will destroy the living cells. This limit switch I told you earlier. This limit switch, what will happen when the door is open? It will it will trigger the electrical panel where it get disconnected. Why? Because if you open the door and you do some maintenance work and the, the fan blade is continuously rotating, so there is a chances of getting hurts. So to avoid this, limit switch is provided. This is just frame assembly how
Excuse me,
it get. Yeah.
Arpan sir.
Huh.
Is the UV light found effective against viruses also, or it is just bacteria and fungi or such microbes?
See, UV lamp basically it destroy all the cells with whatever is coming near to this. So for the viruses, I'm not aware much. So maybe nowadays people are using into the air purifier with UV lamp. They used to claim that we kill the viruses and bacteria and all these things. So I'm not much aware about this, to be honest. So this you see counterflow heat exchangers. So in which there is a one fluid means water is going, other air is going. So there is a heat transfer. Just we must have read into the heat and mass transfer subjects. So this I have shown here for the basically for the coil, the AHU with refrigerant, in which if you see this hot air is coming through this coil and cold air is going out. So this is AHU coil, evaporating coil, while here cold air is coming and hot air is going out. It means this is condensation coil. Because here if you see if you have gone through the pH chart or TS chart, in which whatever we see related to that it explained very well if you go through it. And this is the door. Just we open and here you can see the space around it. Here people used to go and do cleaning and something. It depends on the size of the AHUs. AHU size can be the 10 meter by 10 meter by 10 meter also, or you can say the smaller AHU of 1 meter by 500 mm height by 600 or 800 mm length, like that. AHU flow diagram. There is two types of airflow diagram. One is the air side, other is a water side. So for the first, I will explain air side, then water side already I explained, but still I will touch. So initially what will happen? There is a two fan, return air fan, supply air fan. This is outdoor air, exhaust air. So first what will happen? Outdoor air will come and it will get sucked through the dampers. What damper will do? Damper will allow only that much amount of air which is required to supply to the room. So initially this air will go and passing through the cooling coil. cooling coil, temperature will go down and humidity also go down. Sometimes humidity will get too much down. Here heating coil, if there is a heating is required for the maintaining uh, the temperature and all these things, so heating coil is required. Supply fan, what will do? Supply fan, it will supply the air to the room. For example, here is the room. So here, if you are sitting here, so you will get the desired temperature of comfortable temperature, say 25 degrees Celsius and 50% RH. But once it is passing through you, it will get added heat. So heat will add here. So once heat will get added here, it will go to the return air. If the application is normal, then it will go to the return air. Return air fan, what will do? It will exhaust some part of the air, and some part of the air it will go inside the room. Why we are using some part of the air inside the room? The reason behind this is that if we throw entire air into the atmosphere, this air temperature is say around 25-26 degrees Celsius, while outdoor temperature is 50 degrees Celsius. The load on the coil is more, so means more energy is going to be consumed. So the more energy is going to consume is more costly. You have to pay the electricity bill higher. So it will it will do 60-70% or 80% return value where here you will go, and 20% outside air it will go in, and here it is getting mixed and it will pass through the chilled water coil. And while 20% is getting exhaust. Now you can ask why we are not adding 100% exhaust air return air here, and no need to add additional atmospheric air and no need to do exhaust. So why we are doing? Because continuously if we rotate, what will happen? Carbon dioxide level is going to increase. So as we studied earlier must be, so 0.006% carbon dioxide is allowed. But more than that, what it will do? It will create problem for the human beings and it will uncomfortable for us. So 0.06 if it come, it will be uncomfortable for inhaling the air. So once if it is going to 0.6, then it's very difficult. Maybe people get die or anything can happen. So fresh air is required to dilute the return air. So we are adding the fresh air and we are throwing 20 or 10% as per the requirement. We are throwing into the atmosphere. For example, in the hospitals or the anywhere means if there is any problem in the isolation room, operation theater, in the operation theater also we are rotating, but in the isolation room there the disease is too much spreading. So for that time, what we used to do, 100% return air we used to exhaust and new fresh air we are adding. This is the air cycle. Similarly, the water cycle, chilled water is going and return water is coming. So initially, for example, the volume of the water is per minute, volume of the water rate is, for example, 100 GPM. So for 100% load, it is passing through the AHU, it is getting cooled the air and it's coming. But after some times, the load of the room is going down. So load of the room, consider what number of peoples, the applications you are using. For example, you are using some projector or some heating elements. It is getting down. So the load of the room earlier, say 100%, now it reduced to 70%. So there is no need to pass entire 100% water, 100 GPM to this coil. So it is better to reduce sometimes. So by reducing this, so this balancing valve come in, the PICV valve come into the picture, and it will not allow more than the required water through this. So it saves the water and operate the units like this. This is the AHU GA drawing. What is GA? GA is a general arrangement drawing. So basically all the manufacturers, they used to provide the GA drawing. So if you want to place the unit, so first you have to place the unit on the drawing, 3D drawing or 2D drawing, so that you can identify the space. So if you see here, you can see that this is the return air, this is the supply air, and this is the fresh air is coming inside the room. This is the pre-filter, the secondary filter, minus is the coil, as I said you earlier, plus is the heater, and this is the fan. If you see the space, mixing chamber is required 1000 mm. If the size is more, this size will increase, and the filter size is mostly 700 600 mm is enough, and the coil is also 600. Coil not 600, it's 200 to 300 mm, but additional 300 space is required to air to flow properly. Then heating coil, then fan. Then after that, there is a plenum box. From air it get stable and streamlined flow will go inside the room. So once the air is coming here out, this is the damper. This is the space before the fan is required. Then it go, few air is going outside air and the few air is coming through the mixing chamber here. So you can see the dimensions. So I will tell you how you calculate the dimension in the later slides. So different types of AHU geometry you can see. So horizontal floor mounted AHUs. This is the required for the larger capacity. Basically, you can see it's horizontally mounted and it required a lot of space. While vertical floor mounted, if you see, it required lesser space and but more height is required. And sometimes there is no space. Generally, the space in the Mumbai or the Gurgaon or any Bangalore, any big city, the floor space is much more costlier. So what architect used to do, they used to provide the ceiling space. They used to mount the unit into the ceiling itself. So there is a zero floor space is required. So applications, if you see applications of the and AHU features, construction features depend on the applications. Office buildings, school and universities, here the filtration level is not required as such too much. In the museum also, in the kitchens, the different kind of filters is required because this is oily kind of nature. In the industry, if you see silicon free, halogen, flexible construction, all these things required. In the hospitals, if you see, there is three different kind of filtration is required. HEPA filter, bag filter. So other than this, the fresh air requirement is more. Also, the velocity of the air is less. In the airport also, it should be flexible enough as per the requirement. It get shifted. So whenever air, how we calculate the air velocity, if you see, we know the flow rate and we know the flow rate and area we know. So if you divide with area, we will get the velocity. So velocity is mostly 2.5 meter per second or 500 FPM. Basically, they ask. And the cooling coil, what is inlet air temperature initially 26-27 degrees Celsius, and the outlet temperature when it's passing through the coil, it come down to the 13 degrees Celsius approximately, like that. So how to select the AHU? First, you have to go through the applications. What is the application of the AHU? It is used for the hospital, hotel, industry, or the office purpose or anything. Then according to that, you have to do the heat load. Why heat load is after that? Because if you are going to use for the office purpose, then the fresh air requirement is different. If you are going to use for the isolation room or the operation theater room, fresh air requirement and the air change per hour is required is different. So once you calculate the heat load, you will get to know what is the capacity of the AHU, means tonnage, how much tonnage is required and how much CFM is required. Then CFM, if you know the CFM, and also you will go to know the filtration requirement. What are the different kinds of filters is required. And ESP, you are going to calculate the AHU location to the condition space. So according to that, you have to calculate the external static pressure by considering the duct size and the filter dampers and everything. Velocity across the coil, it should not be more than 500 FPM. That you have to remember. Then as per the application wise, and if you want to reduce the size of the fan of the AHU, then you have to provide the fan requirement, DIDW, EC fan, plug fan, etc. Then noise criteria also you have to mention. The EC fan, plug fan is the less noisy as compared to the backward curve fans. Then you have to provide the space. If there is a floor space available, you want a floor mounted or vertical mounted or the ceiling suspended. How much width, height or length is available that you have to provide. And the mode of refrigerant for the AHU manufacturer you have to give either it's refrigerant type or water cool type. So AHU dimension depends on the many factors. This is the length. If you see, this is the height and this is the width. So we have calculated the heat from here. We got the CFM and the capacity. So once we got the now architect will ask to you how much dimension of the AHU for this much of capacity. For example, 20,000 CFM is there, but after calculating the heat load, and you know the phase velocity should not be 500 FPM, more than 500 FPM. Then you divide 20,000 CFM by 500, you will get 40 square feet of area. So 40 square feet of area is required for the coil and for the filter. So 40 square feet you have to divide into the heat height and width. So either it will be 10 into 4 or 15 into 22. You have to, you will get the ratio. So the space available in the width is more or the height is more. According to that, you will identify, and you got to know the how much is width, how much is the height is required for this much of capacity, this much of CFM. Then length, it depends on the applications. So in the length, if you remember, we have shown the one GA drawing in which there is a measured length is required for the fan. Then the coil, there is 600 mm. Then you required filtration space. Sometimes there is no required of mixing chamber. Sometimes it is required mixing chamber. Sometimes plenum box is not required. Then depends upon the applications. So according to that, length will be defined. And the entire length, height and width, it will be given by the mostly the AHU manufacturer. So once you identify the AHU, then you can't say that this much space is required for the AHU room. Addition to that, you have to add the door to open and the pipe connections and pipe connections and door openings and electrical panels operation etc. It is required approximately 1 meter minimum. And other than this, during the filtration, during the supply and exhaust area, you have to check the space is available for duct connection or not. That also you have to see. And one of the most important things, the drain point for the connections. So in the inside the room, you have to provide one drain opening so that water can pass through this.
Hello.
Yeah.
Yeah, Arpan, you have shown two cutouts, one a D by D and the other C.
Yes.
So, yeah, what are they for?
See, this is D by D or C. Basically, if there is one AHU and this is the rear view here, from here you can see that if different kind of applications, it's a damper basically. So different dampers. For example, this is a return air damper and this is the damper for fresh air. For 100 CFM, for example, 80% air is coming here. So 80% return air damper and 20% fresh air you have to mix for that.
Right. And this phase velocity, it will be same for coil as well as for filter. Like they will have almost same cross section.
Yes. So from these cross sections, you will find the height and width. So it's very good, means it will give you the idea that this much of the width and height is required. And according to that, if you, for example, you have less width, height is more, then you will inform to the AHU vendor that we have this much of a space. You have to accommodate this AHU into this. So according to that, they will modify the AHU box. Completely.
Okay.
Length depends on the different kind of applications. But other than the AHU dimensions, you have to add Just I mentioned earlier, you have to add the connection space, panel operating, or fresh air supply so that there is enough space to operate all these things.
You written something RIS 4000H,
This,
5000H.
this may be from the photo itself. I don't know. This is a sample report. Whenever the AHU supplier is doing the coil selections. So basically in the AHU, if you find, one of the major part is the coil selections. Coil will give you the tonnage capacity. You can manage the filtration area or the plenum box or the box size, each and everything, but you have to design the coil, and for designing the coil, this much of the you have to calculate the sensible heat factor, sensible heat, latent heat, all these things you will get from the heat load itself. Then how much CFM is passing through this coil. If you increase the CFM, for example, sorry, velocity from 500 to 1000, then it will pass through the filter and then coil. What will happen? The life of the filter, it will get reduced. Other than this, the particles that is getting arrest of, say example, 0.03 micron, it will get arrest up to some velocity. If you force continuously, then it may come out. The purpose of the filtration may get uh, avoid may get reduced. So external static pressure, how much static pressure is required? If we make the coil more congested, then the static pressure will be more added. That need to be checked. Pressure drop across the coil. Pressure drop, two types of pressure drop happening into the coil. One for the air when it passing from one side to getting outside. Other for the water. Water is getting inside the tubes, and there is a number of circuits, and it will get come out. So if the pressure drop will be more, then then pump required for circulation of the water is more, of higher static. It will consume more energy. So you have to be optimum. If you use very low pressure drop, what will happen? Then the flow will be a streamline. Then in the streamline flow, heat transfer will be getting very low. So it should be turbulent, but it should be not that much turbulent so that the copper tube will get damaged or the pressure drop will be more. It should be optimum. So tube dia, how much tube dia is required? The larger the tube dia, pressure drop will be more. Fin details. Fin details means that there is FPI. FPI means fins per inch. In 1 inch, how many number of fins? If number of fins more, then the heat transfer will be more. But it also add the pressure drop. So it should be optimum for the fan. It should get the heat transfer, the airflow will be best and the heat transfer will be worst. So you have to do the selections. At one point of time, it will give the best efficiency. After that, it will getting reduced. Water in out temperature you have to provide for getting the capacity. Fouling resistance. What is the fouling resistance? Fouling resistance is basically is adding the, for example, right now your coil is very good, means new. There is no foreign particles is deposited inside the tubes. But after some times, after using continuously 1 or 2 years, the water quality, what will it will happen? The inside the surface, uh, the solid particles or any foreign particles it get deposited continuously inside the tubes. So it will reduce the efficiency of the AHU of the coil. So for that you have to do additional factor of safety, additional design, so that after 2-3 years it will give the desired conditions. One of the most important thing is the connection directions. When the AHU you are going to buy, and if you have not provided the connection size from left hand side or right hand side, or water connection size, and the space available for you is from the right hand side, and you have not provided that I want right hand side space. So if manufacturer given left hand side, then the purpose of the entire designing and everything, it will get destroyed. So you have to do some modification at site, and it will give a lot of pains to you. So if you have any questions, you can ask.
Arpanji, this AHU will be there in VRF systems also. We call it AHU.
Yes. See, AHU is basically air handling system. So anything means in which air is getting handled. So in the VRF system, what I told you, the refrigerant, there is two kind of AHU, one with water chilling, one with refrigerant. So the refrigerant chilling, you can say it connected with the VRF. In VRF, there is no water.
So should one use, let's say, small size fine coil units or central bigger size AHU?
It
What is the
depends.
criteria to
Yeah,
decide?
yeah. Or if you are going into the hospital, in the hotels, in each and individual rooms, you will find separate fan coil unit is there. So when you go into the hotel, you just open the AC, it will get continuously running. There is a one every FCU in each and every individual room. While into the corridor, if you go to the corridor or the ballroom or the some party area, there is AHU. Why AHU is there and why not FCU is there? So in the big area, if you provide the FCU, you have to provide n number of FCUs. So, and if you provide n number of FCUs, if there is a problem in the FCU, you have to do the cleaning, maintenance, and it will disturb all others. So in big areas, AHU is required. In the small areas, FCU is required. So it can cater, for example, in our home also, we are using the split AC in each and individual rooms. But in the offices of the 10, 12 or 15 rooms, they use the AHU system. Why AHU system? There is a it can it can give you the space. Only one unit you have to provide, and you can clean from the outside itself. No need to provide in each and every individual room. From there you can control the CFM by the VFD or inverter, whatever you say, and by using the dampers. And there is a sensors and pressure sensor, pressure switch, all these things required to increase or decrease the speed of the AHUs. So different, for example, in many areas, there is a treated fresh air, TFA used to call treated fresh air AHUs. So what is treated fresh air AHUs? So sometimes what happen in each and in some area, there is a in kitchen area, people used to provide treated fresh air. There is a temperature, air is coming from outside with 24-25 degrees Celsius into the kitchen area. It will get warmed by the cooking areas and the oil and everything get mixed, and 100% it is getting exhaust. When 100% air is used for treating the 100% air is treating via AHU, it is called TFA, treated fresh air. So when 80% or 20%, the different names people used to give.
Yes, students, any further questions? I believe this topic is almost new to you, though you just know the basics of AHU, the different components of that, but then there are so many details in that and so many factors affecting various like design related decisions or sizing related decisions. So Arpan Kedia sir has thrown light to many such areas and given you details about different components. So if you have some question related to any of these slides, you can ask. Having practical knowledge and exposure, he is the best person to give answers to your queries in this area.
You have any small questions you can ask. See, in the house we are using the air cooler. So in the cooler also there is a fan, and air is cooled by the using the water. So similar kind of concept is here, but in the cooler, what will happen? Humidity is not getting controlled. So if you see, if there is a moisture is there too much, then the room inside, if you room is getting close, the room is completely moist. But in the AHU, the humidity is getting removed into the coil itself. So if you have any questions, you can ask. So I think so, no questions.
Yeah. Actually, this is the semester end for the students, so
Okay.
many are busy with the submissions, and probably they may not be in the right frame of mind also right
Okay.
now. Yeah. So that's why I've recorded this so that the people who could not attend would be able to later on also watch this. And I've also included this as one of the practicals in lab because though we have a simple AHU, we are not able to show the details and also much details about that. So it's covered with your lecture, and so it's going to be very helpful and add to their knowledge in this field, because AHU, I believe, is a very important component. More and more species getting air conditioned and central AC system, so this is an indispensable component in such air conditioning systems.
I just want to add one more thing. There is n number of companies in India who is manufacturing AHUs, and mostly they are not hiring from the colleges itself. Either you can connect with the manufacturing units and request to them, or the students itself get connected to the AHU's industry and they can request that we have gone through the training and all these things. So they may take interest.
Correct. There is this Citizen Industries in Ahmedabad,
Yes.
and now it is taken over by Daikin.
Daikin.
So I think that shows the interest of even multinational companies in such business.
Yes. So there is many companies, Jeko, Daikin, now Citizen is Daikin, then Webs, then System Air, then Flatwood. So many companies you will find, and they are very much interested into this. And even they want to see the AHU rooms. You can go to the any mall and you can connect with the ISRI members, those who are doing the servicing parts. They will take the students to the AHU rooms. There you can find it. Whatever I told you here, they will see in the physically.
Right. Of course, with limited time, we are able
Yeah.
to arrange very limited industry visits also. Yeah. But we would try our best.
Yes. Yes.
So thank you, Arpan sir, for your insights into this topic.
Okay.
Dinar?
Hello.
Yes.
Am I audible to you?
Yes, you are audible.
Yes, sir, I am an architecture student from MS University, Baroda.
Okay.
We are connected to Jignesh sir for our topic of HVAC, means air conditioning and ventilation. So I just wanted to ask that we recently had a topic of this air chilling plant, means water chilling plant and all. So, what kind of consideration do architects follows at the time of designing or providing such systems in a building? That for us it is obviously a new topic, and obviously we are going to introduce it in our designs also in recent times. So, what according to you are the consideration which architects or as a student right now we must follow to understand its concepts and all?
See, when the architect, whenever you're going to design the any buildings or any, for example, you are considering hotels. So in the hotels, what are the maximum space consuming by the HVAC systems? In the HVAC systems, not the chilled water plant or AHU. You will able to locate the space for the chilled water plant or the AHU you can provide. But other than this, there is a ducting going on. Duct work is for the AHU supply air. Sometimes supply air is ducted always, but the return air sometimes ducted, sometimes no, it is free flow. So for that you need the space requirement above the ceiling. So whenever I used to work in the project department earlier, there is always fight between the us and the architect. They used to ask, we want the false ceiling height should be 2800 and you have to accommodate all the ducting work within 300-400 mm. And we are saying it is not possible. We need at least 800 or 900 mm. So 70-80% space is consumed by the ducting above the false ceiling. So whenever you going to the hospitals or hotels, so in the corridor, the height of the false ceiling is lower as compared to the room. Why? Because in the corridor, most of the duct is going and the branch, small branches going inside the room. So the height of the room is getting more as compared to the corridor. So whenever you used to design, you have to check the space for the AHUs. There is not only AHUs, the chilling plant room. You have to give the space. Then the other than this AHU, you have to provide the space for the fan, normal exhaust fan, normal fresh air fan. From the air, it is going to come, going to out. And then many equipments, big equipments, the architect used to provide. You have to give it to the terrace earlier. Nowadays, in the terrace, they want solar power panel as per the government requirement. So in the some 50-60% area is consumed by the solar power panel in the terrace itself. So you have to take the space and the ducting. If the AHU is of larger size, then ducting height may be more than 1 meter, 1.5 meter, and the width also may be 1.2, 1.3, 1.5, uh, depends on the CFM requirements. So what people used to do, people used to avoid the height and they used to provide the length. So you have to take care about the height and all these things. So initially, if you think that the height we will manage, then it is very difficult for the person who is working in the HVAC industry. Also, you have to give the response or reply to the builders that it is not possible, it's my mistake, all these things.
Okay, right, sir.
Okay.
Yeah, so if there are no further questions, we can conclude. Ninath, you can take over.
Yes, sir. On behalf of the entire ISRE Vadodara chapter, I extend my warmest regards to our today's speaker, Mr. Arpan Kedia, air handling units. It was an honor to have you here for such an exhaustive lecture on air handling units. I am also thankful to the President of ISRE Vadodara chapter, Mr. Hemant Bedekar, Secretary Dr. J.R. Mehta, Dr. Ronak Shah, Student Chair, and the entire ISRE Vadodara chapter for giving us such opportunities of tech-enriching talks. Last but not least, I am thankful to all the participants who have attended today's expert lecture. Thank you.
Thank you.
Thank you, Arpan. Thank you all.
Okay.
Thank you for your time and energy.